Okay, welcome back. We're going to start Quest 4 right away. I got Bacon working. Yesterday it wasn't working. It's working now. And I've got my whole config set up. So Quest 4 is called The Teeth of the Wind. Part 1, story section. The heavy loads mean the wagons trundle slowly along the muddy road. You sit on one of them and take the lovely scenery around you. The village where your story began is still visible behind you, the grain fields spread out in front of you, rolling like a golden sea. 3 windmills are visible on the hill above the fields. A light breeze is blowing through the air, but their huge blades are absolutely still. The knight points to one of the mills and says, "That's where we stop. Garrison needs flour, and because you planned the packing of the crates so well, there's still some room left." From a distance, you see an older man with a gray beard covered with flour dust. Maybe it's gray because it's covered in flour dust. He looks distressed. Before you had a chance to greet each other, he raises his hand in a gesture of apology, shouting, "Apologies, sir, the mill is out of order." You talk for a while to find out what happened. It turns out the gears transmitting the wind's energy to the millstones has been replaced, but the mechanism has not yet been properly calibrated. The miller does not want to risk wasting the wheat grains and wants to first calculate everything precisely before restarting the mill. The knight looks in your direction and you exchange a knowing nod. Miller hands you a list of numbers represents the gears of the first mill, your notes. Each number corresponds to the number of teeth of the given gear. First gear on the list is connected directly to the windmill. The last gear is responsible for driving the millstones. The gears are connected to each other in the order of the list. 10, 7, 13, 6. Okay. To calibrate the first mill, you need to calculate the number of full turns the last gear will make if the first one makes exactly 25 full rotations. Example based on the following notes. 128, 64, 32, 68. Second gear is half of as many teeth of the first one, so every full turn of the first gear, second gear will make 2 turns, right? And we just keep dividing by 2. So, right, and then that is that. So this one, it's always going down. A faster and equally accurate method for calculating grinding value. Is this like the least common multiple or something? What's the least common multiple of these numbers here? Or greatest common divisor or something like that. 232,050. Oh, okay, so it's not that. But don't they have the GCM here? Or GCD as well? It's 1. All right, so that didn't work. So neither one of those work. That's not good. There has to be some, because yeah, you can't just divide 102 by 75. I mean, you could start doing it in terms of floating point numbers, but that's not going to give you an exact answer. And if the second gear is bigger than the first, then you divide the other way, or you multiply. Right, this is half. That's clear. Why is this hard? Well, let's see if we can do it. If A is less than B, I'm going to see if we could do it with floating point. And we probably can't. But if A is less than B, if the first one's less than the second one, then it's going to go faster. If the first one is larger than the second one, then it's going to go. Oh no, yeah. So because it's half, it'll make 2 full turns. So you divide this by this, and that's the gear ratio, and so therefore that's what you multiply by. Multiplying 16 by 2025. Yeah, okay. I mean, it might work out. Let's make a little function called calc gear. And we're going to just give it a vec of F64s, ratios, F64. And it'll give us back an F64 of the final gear thing, and we'll just multiply that by 1025, right? So we can say for let result is equal to 1, I guess. And then we could say for first, second in ratios Windows 2, or do I have to say ratios iter Windows 2? Let's just print those out for now and then return, just return 0. And what I'll do is I'll just say calc gear, and we'll use the first set of gears, 128, 64, 32, and this should end up being 16, right? 8, because it's dividing by, we're multiplying by 2 that many times. Result times equals first divided by second. Right? It doesn't like that. We can't do Windows. It's available on, directly on F64. I don't have to do an iter on it. Okay. Oh, it doesn't like that. Oh, it has to be a, okay. For pair. And this becomes pair 0 and pair 1. Oh, yeah, just return result. Oh, I was going to print it out, wasn't I? That's fine. I'll just print it out. Print it here. Right? And if I run it, we get 16. And then we multiply that by whatever. But here's the hard one, is that it's this list here. So let's try that and see what the ratio is. Println this 2025 times calc gear of these numbers. And we'll just put commas between each one. Like that. There we go. Oh, yeah, and they have to all be floats. And if we run that, yeah. So it is 5. Oh, so we could just say floor, right? No, we can't. Why is it different now? Oh, because I floored that. I didn't floor the whole calculation. I got to floor the whole calculation. Okay. Yeah. Okay. So let's get a real input. I mean, this might be the easiest way to do it, rather than try to be fancy with gear ratios. Make their input. Move downloads everybody codes into input. Cat input. Ooh, there's a lot of them. Oh, I mean, it's a ratio. A ratio is a ratio. Yeah, and I'm worried that we're going to lose precision, and by losing precision, we're going to get the wrong answer. But I'm willing to give it a shot. Let lines is equal to lib read. I think I can do read numbers. Does that read one number per line, or does that read one? Yeah, that reads one number per line. I think that's all we need. This is vec unknown, vec of I64, and now let's just print it out. Make sure we have it. Yeah, that looks good. Okay, so what we'll do is just say part 1. I'm going to comment this out. And then we'll say part 1 here is equal to calc gear lines times 2025 all floored. Oops. Yeah, isn't that the way it's supposed to? Oh, I did I64. This should be F64. Okay, let's see if that's the right answer. And it is the right answer. My quacks turned into facts. Nice. Okay, so that's all we had to do. Oops, it jumped to the bottom. I didn't want to do that. I wanted to look here, right? This guy grows up. He's a little chick. He's bigger. He's got muscles. Now he's looking this way. Okay. And there's the other guy. All right, neat. Clippy doesn't like this because I have an extra pair of parens here. Okay, Clippy's good. Git, let's say, right, -am, quest 4, part 1. All right, what's part 2? The first mill is starting to operate and produce flour. You promptly proceed to calibrate the next mill. Your notes. The gear's operation and list format are the same as for the first mill. Only the method of calibrating is different. To calibrate the second mill, you need to provide the minimum number of full turns that the first gear must make, so the last one happens this many times. So it's just the opposite way. For the last gear to turn this many times, the first gear has to be that way. Okay. We can still calculate the ratio, but instead of multiplying, we're going to divide, right? Is that all we need to do? Let's find out. Let's put these back. And instead of multiplying, we're going to say calc gear divided by this big number. And this is where things might fall down, right? No, it's the other way around. Yeah. If I run that, we do get this number here. Is that the same as this number? I can't count the zeros. 3, 6, 9. There's 9 zeros here. 3, 6, 9. Yes. Okay. And let's just test this other one to make sure we have it we're doing it correctly here as well. Oops. This number here. Divided by. And it's 1, 2, 7, 4, 5, 0, 9, 8, 0, 3, 9, 2. Ooh. Ooh. I guess it's not floor. We got to round it. Can we round it? Oh, no, it's got to be +1, right? Because we have to go 1 past that situation. But the thing is, if I do 1+ on this guy, is that going to fail? Yeah. Oof. So if it's exact, that's one thing. But if there's any remainder, we have to add 1 to it. What's the best way to do that? Let's grab the input. I mean, we could just try both. It just means being delayed by a minute. But that's not the is it the same? No, it's different input. Okay. Let's do this. 2. So we have to say if we divide and there's any non-integer part, then we have to add. Yeah, so if we just add 0.99999, can we do that? And then floor it. Will that work? Oops, I guess I have to stick a 0 in front. Yeah, but I did a floor on it. It should have floored that, right? The first one. Oh, I didn't floor the inside. I floored the outside. Okay. Yeah. Okay. Should we try that? I don't know how many 9s we need. I tried 4 here and 5 here. Let's just try it like this. Println part 2 is equal to this number divided by calc gear lines. I shouldn't call it lines. I should call it gears. Didn't rename that one. .floor. Came up with this number. Let's see if it's right. I hatched a brilliant answer. Nice. Place 162. Yeah, I start these like an hour late. I know it says it's 6:30, but I'm in Cordova, Tennessee right now, so I'm ahead by an hour or behind by an hour, depending on your point of view. All right, let's comment that out. And it looks like Clippy is clean. I can see it over on the left there. So let's commit that. Part 2. And let's take a look at our progress. This time we'll do here. So we'll see this thing show up. 2, 3. Okay. The second mill is also starting up at full capacity. The miller is regaining his positive mood. Only the third mill remains to be calibrated. The mechanism of the last mill differs from the previous ones. The list of gears provided by a miller starts and ends with single gears, just like before. However, between them are pairs of gears mounted on common shafts. Thanks to this, they always turn at the same speed, meaning that if one of the gears makes, for example, 10 full turns, the other will also make exactly 10 full turns. The list represents gear pairs as the numbers separated by a pipe character, such as 1545. The number on the left represents the gear connected to the previous gear on the list. The number on the right represents the gear connected to the subsequent gear on the list. Sample of the gears. I see. So we do a 10 to 7, and then this rotates at the same speed. So it's 14 to 8, which is a down, and then 16 to 6, which is another down. That's why this guy is spinning so much faster than this guy. To calibrate the last mill is necessary to calculate how many full turns of the last gear makes if the first one turns exactly 100 times. Example based on the following notes. So we have 5, 5, 10, 10, 20, and then 5. Second gear turns once after the first gear turns, because the left side gear of the first batch, blah, blah, blah. So this only turns a half a turn, or this 10. No, a 10 turns fully once around, right? And it goes to a 20, which is going to turn fully 20, right? And then we have a little tiny 5 here, which is going to go 5 up from that. 20 divided by 5, which is 4, which means 100 goes to 400. That makes sense. And this one generates 6818. So how do we work this? We say 5 to 7, which means if this goes 100 times, the 7 is going to go this ratio, which is going to be an oddball ratio. But then that means that 21 goes that many times. And so that becomes the new multiple for this guy, this ratio. Okay, well, let's get our input. And now we have to parse it. So it's going to be a little more complicated. Let lines is equal to ASC lib, read lines, oops. I'm trying to think of how we can represent these as just pairs, but the first one and the last one aren't pairs. So how do we deal with that sort of a ratio issue? Do I stick 100 in here and then make an X here to say unknown? I don't know. Well, first we need to see what's going on. So the 5 and the 5, this turns ones. Here, this for every 100 turns, this is going to turn 5/7 times 100, right? Because of the way the gear ratio works. So not quite 100. And then the 21 is going to turn that many times, and then so this next gear is going to turn 21/18 of that many times. Let's see if we can print that information out at least. If we have this as our input, let's just put this as test I'm going to skip this one because this is too easy, meaning that we're not going to get a good example of the weird ratios we have here. Input test3.txt, right? And then, did I download this 3 yet? I did. Okay, so move downloads everybody codes into input. Yeah, we got a lot of gear ratios. We start with 660, rotating 100 times. All right, it's going to be interesting. So let's read the test input. Right, and now we need to know how we're storing this. So what we can do is grab the first one. Let first is equal to lines of 0, pars as f32, f64. Oh, we might not be able. No, we should be able to. I'm thinking it needs a 0.0, but I don't think it does. Unwrap for line in lines 1 dot dot. Len minus 1. We're going to say left, right is equal to line split once on pipe unwrap. And then we'll push it onto a, I guess we could do it in a functional style. Map line that, collect into back. Left is going to be one gear thing, and then right would be another one. So we can say left parse f64 unwrap, right parse f64 unwrap, and that way we'll generate a bunch of tuples, and then the final one is going to be last is equal to lines len minus 1. That parse f64 unwrap. Let's see what we get. Print len first, mapping last. And this is the test input, so it should look like this. Here. All right, so 5, and then 7 to 21, 18 to 36, 27, 27, 10, 50, 10, 50, and 11. These aren't minus signs. These are the, I put dashes in here. Probably shouldn't have done that. Okay. So we're able to parse it. We're able to get the gear ratios. The question is, how do we handle this? If we start with the first gear ratio first, and then we know the next one for M in mapping, left, right in mapping, we can divide ratio by left, and then we know the number of turns we're turning. So let mod turns is equal to 100. And that may, the right one is going to turn that many turns, right? So turns divided by equals ratio, or multiplied by ratio. Right? Then after we've figured out that many turns, this gear is going to turn that many times, right? So if we look at this one, maybe this one's easier to reason about. This is 1 to 1. So the ratio is going to be 5 to, right? We're going to divide 5 by 5 will get 1. So 1 times 100 is going to be 100. It's going to turn 100 times. This gear is going to end up turning twice as many times. So it's going to be, so do we just divide right by left and multiply that by turns? And left being a ratio. Divide right by the, yeah, maybe we do that. And then we multiply that by the ratio. And I can println left, right, turns equals turns. And we just see, and then the final one is going to be that last ratio divided by our, divided by equals last. And then we multiply that ratio by turn, or turns by that ratio. Part 3 is equal to turns times ratio. I have no idea if that's right. No, that's too wonky, and this number we came up with is too big. The 7 to 21 turns got us 2940. That's wrong. Okay, so let's do this simple one, because I'm saying it's not going to really help us because we're not going to learn anything, but I think it will help us. Let's go say cat greater than input test3 easy dot text. Right? Okay. And let's just change this to easy. If I run that, 5 to 10 turned into 1,000. Okay, so it needs to turn into 200. Right? The first one has to go from 100 turns to 200 turns. Then this goes. No, I got it before. Oh, right. This is 10. This time 10 is turning 100 times because this is turning 100 times. So I'm doing this part wrong. Right, ratio divided by equals left, right? So that means our turn, so it's going to end up being 1. So that means our turns are going to be, for this guy here, for the turns are going to still be this thing here. And then, but the ratio, do we even care about this then? We must, right? Because the ratio between these two matters. If this is 1, what happens to the right side? Yeah, this turns 100 times. This I'm saying turns 10 times, which is wrong. I have it backwards. This turns 100. This doubles it to 200. Oh no, this will turn 100 times, which means this is going to turn 100 times. That's not the way it works. The way it works is this gear to this gear is what matters. Right? The 10 to the 10 means 100 here. And then the 20 to the 5 multiplies by 4, which gives you the 400. So 21 to the 18 is the ratio of the next turn. So we actually need to know what the next, to divide by the left. Right. Yeah, that's what I'm trying to do, is I'm trying to divide by left, given the previous ratio. I did that here, fine, because we did the 5 divided by 5. This ended up being 100. But this should be 10 divided by 10, which is still 100. So let me print out the ratio as we're doing it. Yeah, I divided by 10, and I don't want to divide by 8. Oh, it should still be 1, right? Because this ratio is 1. I see. And then maybe what we have to do is multiply the ratio by the gears, and that way we can divide by, or we just set it, right? Ratio is equal to right. Yeah. Okay. Does it work for the hard input? $68.18. That is correct. And we again have to floor it. Okay. So that means we should be able to run it for this. So we got this number here. Is this right? I got that clock power. Yay. Oh, place 158. Yay. It took me a half hour to do all that. All right. And we're going to check our progress because I know it's silly, but I enjoy it. It's something fun. There we go. All right. Very nice. Okay, let's, Clippy looks like it's clean over here. Git status, commit-am part 3. Very nice. Okay. Thank you everyone for watching this. I had a great time doing this, and I hope you had a great time too. And I will see you in the next one. Take care.